Let's go ahead and go over center spread and shape of distributions. First thing I want to go over are box plots. And all a box plot does is it visualizes the distribution using medians and quartiles, which we'll get into. You may have also heard it called a box and whisker plot, but it just shows how the data is distributed, and it uses 5 things to do this: the minimum, the maximum, the Q1, Q2, and Q3. But we'll go ahead and explain this all individually here. You're going to have a set of data. You're going to order it from smallest to largest. You'll find the median, the Q1, Q2, and Q3. Let's say our data set is 2, 5, 6, 8, 9, 11, 13, 15, 18, 20, and 22. Here we have our data set. First thing to do would be to order it. But like I said, we just already have it ordered. Second thing here, we want to go ahead and find the median. We have 11 values, so it's going to sit right here in the middle. So our median is going to be 11. So that's our first important value. So how do we find the Q1? Well, to find the Q1, we're going to look at the lower half of the data. We just found the median. So our lower half is going to be everything over here. So we have 2, 5, 6, 8, and 9. It's going to be 5 values. So our Q1 is going to be the middle value, or 6. So our Q1 is 6. Next, let's look at our Q3. So we're going to take the upper half, our 13, 15, 18, 20, and 22, and we take the middle value here, which for us is going to be 18. Now we know my Q1 is 6, my Q3 here is 18. From here, we can go ahead and find our minimum and maximum. Now these are going to be a little bit easier. They're going to be our highest value and our lowest value. So our minimum, we can say is 2. Our max is going to be 22. And that's it. You might also be asked to find the interquartile range. And all that's going to be is our Q3 minus our Q1. And this is the range of the middle 50% of the data. So we said our Q3 is 18. We said our Q1 is 6. So our interquartile range is just 12. Simple as that. Now, on top of this, there's going to be some shapes of our distributions here. Usually when you see a box plot, it's going to look something like this. You'll have your minimum and your maximum by these little whiskers out here, as you might have called box and whiskers. And then your data is going to be split up here into 3 things. This big bar in the middle, the outer bar is going to be your Q1, the middle one is going to be your Q2, and then the final bar would be your Q3. From the Q1 to the Q3 would be your interquartile range. Now there's 3 different distributions we can have. One is going to be symmetric. All that means is the data looks the same on each side. It's kind of split the same. One can be skewed right skewed, which looks like this, where our right whisker here is going to be longer, and then one will be left skewed, in which the left whisker is going to be a lot longer. It's going to look something like that. Now let's dive into standard deviation. All standard deviation is it measures the spread around the mean. So standard deviation is pretty simple, but it is a longer process. Let's go ahead and take this data set. Let's do 4, 6, 8, 10, and maybe let's do 12. Just keep it nice and even. The first step is to find our mean. If we add all these numbers up, we're going to get 40. We have a total of 5 values. When we divide, we're going to find out that our mean is 8. The next step is to find each deviation from the mean, or how far each number is from the mean. So I'm going to take 4, 6, 8, 10, and 12, and I'm just going to subtract 8 from all of them here. We know 4 minus 8 is -4. Next will be -2, 0, 2, and 4. So those are our individual deviations. Next step here is going to be to square them. So I'm just going to go ahead and square all these numbers here. It's going to give me 16, 4, 0, 4, and 16 again. And now we find the mean of these squared deviations. So we add all these numbers up, and then we're going to divide them by the number of terms we have, 5. And that's going to give us 8. Next step is to take the square root to get the standard deviation. Now we do square root of 8, and that gives us about 2.83. So the standard deviation for our data is 2.83. So to find standard deviation from top to bottom, we get the mean, we get our deviation, and then we square them. We find the average between these deviations, and then we find our square root. That's it. That's how we find standard deviation.